A very good morning, students, and welcome to the first session of your subject Biosensors and Transducers, that is UBT 508. Okay, and we are going to start with the first unit, that is Physiological Transducers. Now, just to give you a brief introduction, the whole subject Biosensors and Transducers actually revolves around the idea of measuring physical quantities that relate to the physiological state of a living organism. So basically, whenever if you see around you all the medical devices or basically the medical instrumentation that revolves around one basic requirement, that is measurement of signals, or you can say efficient and reliable measurement of signals. Okay, so that plays one of the important roles in the medical science. Right. So medical instrumentation, whenever we talk about, the very first step that involves in a medical instrumentation is, reliable and efficient measurement of signals. Right. So in this particular subject, we will be studying the various aspects that are involved when we are talking of a medical instrument, which is including, the measurement of the signal at the first step, then how to process that measured signal that we are getting, and ultimately bring it to such a form which is which can be displayed in such a form that a user or an end user can understand it, without any effort. Okay, so that is what the whole subject is going to be about. Now the first unit that we are going to start with is physiological transducers. In this unit, the topics that we are going to cover are transducers, that is what a transducer is, both the types, active and passive, pressure transducer, catheter tip pressure transducer, temperature transducers, pulse sensors, respiration sensors, and digital transducers. Okay, so to start with, the first thing that we need to understand over here is physiological variables. Now, what is a variable? Variable actually is any physical quantity that changes, the value of which changes with respect to time. Okay, and so any physical quantity or any variable which is related to the physiological state of an organism or a physiological process of an organism is called as physiological variable. Okay, so a variable associated with the physiological process of the body is called a physiological variable. For example, it could be body temperature, it could be activity of the heart, it could be blood pressure, it could be respiratory airflow, etc. etc. So any physical quantity or any quantity that is changing with respect to time and that relates to the physiological condition of a living organism is actually called a physiological variable. Okay, now the major function, like I told you, of medical instrumentation is measurement of these variables. Rather, I should say reliable and efficient measurement of all these variables that are originating basically from human body. Okay, so physiological variables, they may occur in many forms. They may be occurring in the form of ionic potential. They may be occurring in the terms of mechanical movements, hydraulic pressures, temperature variations, chemical reactions, etc. etc. So all these phenomena are actually taking place in human body, in our body. All the processes, so many numerous processes that are taking place at every instant of time in within human body is actually giving rise to so many kinds of physiological variables. Okay, like for example, if we talk of blood pressure, now the blood pressure is a medical term that we talk of, but the blood pressure changes might actually be giving rise to certain mechanical movements within our body, certain pressure movements within our body. Okay, so these are the terms in which we are going to measure blood pressure. So whenever we design a medical instrument, we will be talking in terms of medical movements, pressure changes, temperature variations, and then relate it to the particular physiological process, like maybe blood pressure or respiratory airflow, etc. etc. So physiological variable means any variable or any physical quantity that changes with respect to time and relates to the physiological condition of the human being is called a physiological variable. Now, the first very step that is involved while designing a medical instrumentation or a medical instrument or a measuring instrument is transducers. Or in general, sometimes in general terms, we use the word sensor also. But in this particular study, we'll be focusing to the use of the term transducer. Now, what is a transducer? A transducer is actually a device that performs the conversion of energy from one form to another. Or you can say it converts one form of variable into another form of variable. Okay, like it might be converting pressure changes into electrical form or changing electrical variations into pressure changes, right? So on and so forth. So the change in the type of energy or conversion in the type of energy actually is produced by a device called transducer. Now, transducer is required to convert each variable into an electrical signal, which can be amplified or processed and then converted to a suitable display. Now, over here in this study, we'll be focusing more on the definition of the transducer in such a term that any physical variable, has to be converted into an electrical signal. So for us, transducer will be a device which can convert the physical variable or physical quantity into an electrical signal, because all the devices that we see look around us, we have BP machines, we have ECG machines, so on and so forth. All of these are basically nothing but electronic signals from inside. So to work with these devices, we actually need to convert the actual physical variable into some corresponding form of electrical signal, which can be amplified, it can be transmitted, it can be processed, and then finally converted into some suitable display form, right? So over here, we'll be focusing on the definition of transducer to such a definition that it can convert any physical form of variable into electrical signal, right? Now, for this process of conversion, there are basically two principles involved. Okay. And on the basis of those two principles, we classify the transducer into active transducers and passive transducers. Right. So active transducer is which is based on exactly the principle of energy conversion. That is, in the when the active transducers are functioning, an entirely new form of energy is created or generated. For example, you have a piezoelectric crystal. Now, piezoelectric crystal, when it is subject to pressure variations, voltage is produced. We don't supply any voltage to that crystal. It doesn't need any external power supply to operate, right? So the pressure or variations, which is actually a physical quantity, gets converted into entirely new form, that is an electrical quantity. Okay, so that is active transducer. Whereas passive transducer is based on the principle of control of the excitation voltage or the modulation of carrier signal. That means there is a device which already has some voltage or current present into it, which we are supplying in terms of maybe a battery, and whatever the physical quantity is taking place is not creating an electrical quantity but only creating a variation in the existing electrical quantity. Okay, for example, if your physical change that is taking place, it is changing maybe the resistance of the circuit. So when the resistance changes, the voltage actually changes. It does not create the voltage, but it creates a fluctuation in the existing voltage, right? So that is passive transducer. So we have two types of transduction principle: active transducer and passive transducer. Active transducer is based on the principle of energy conversion, that is entirely a new form of energy is created, whereas passive transducer is actually based on the principle of control of an already existing voltage. Okay. So now we have some popular phenomena existing in the world, you can say existing in nature, which help us to create active transducers. So the most popular phenomena that will be used in designing the active transducers for biomedical applications, they are magnetic induction, piezoelectric effect, thermoelectric effect, and photoelectric effect. Okay, so we'll be talking about these one by one. These are actually the phenomena, they exist already in nature. Okay, and all these phenomena, they help us in designing active transducers for biomedical applications. So the first thing is magnetic induction. Now, what is the operating principle? If an electrical conductor is moved in a magnetic field in such a way that the magnetic flux through the conductor is changed, a voltage is induced in which is proportional to the rate of change of magnetic flux. Now, you can see in the figure that whenever we have an electrical conductor which is moving in a magnetic field, okay, so you can see a magnet, okay, you can see a coil that is basically a electrical conductor, and you know your magnet, the moving magnet is actually creating a moving magnetic flux. So whenever we are having the electrical conductor being moving in a magnetic field, a voltage is induced. So you can see that over here, we are not giving any additional current to it or any additional. You can see there's no battery attached. Only the physical movement of the magnet in the vicinity of an electrical conductor is actually giving rise to a voltage which is proportional to the change in the magnetic flux, right? So this you can actually use for measuring things like displacement. Like this moving magnet can actually be connected to the displacing part of the biomedical system, and when it moves, the correspondingly the magnet moves, and a voltage is produced. So magnetic induction is basically one of the phenomena that help us in designing active transducers, right? So this principle can actually be used for measurement of linear or rotary motion. The voltage that is produced in each case is proportional to the corresponding velocity. Okay, and most important medical applications that you can apply this to is micro heart sound microphones, pulse transducers, electromagnetic blood flow meters, right, etc. Another very important role of this phenomena comes at the output of many devices. Like you see meters, which have pointers deflecting in a rotatory manner or in a semicircular arc. Okay, so these kind of movements are actually initiated with the help of magnetic inductions. So the analog meters, the pen motors, thermal recorders, etc. These all involve the principle of magnetic induction at the output stage to actually, show the desired display, right? Next one is piezoelectric effect. Now, piezoelectric operating principle is whenever a pressure is applied to certain non-conductive materials so that the deformation takes place, a charge separation occurs in the materials and an electrical voltage can be measured across the material. You can see in the figure, the blue arrows, they actually indicate some pressure. So if this crystal is a specific type of crystal which exists in nature, okay, and we call it piezoelectric crystal. When you apply force, okay, and that force results into deformation, that deformation actually gives rise to voltage. So you can see there's a mechanical movement that we are giving to it, and electrical voltage is being produced without giving any external power. There's no battery involved, there is no source of power involved, just that the mechanical movement that we are subjecting the crystal to is giving rise to an entirely new form of energy, that is electrical energy, that is voltage is being produced. So this is what is piezoelectric. And this effect is actually reversible. Okay, so the same crystal can actually work like a mic as well as a speaker. This is one very popular example to understand piezoelectric effect. So when the sound variations, they strike the crystal, they create pressure differences, they create deformations, and that produces a corresponding electrical signal, right? So it is basically it works like a mic. When you talk, when you speak in a mic, the sound variation, they strike the crystal, they create a corresponding electrical signal, and that is fed into your amplifiers or woofers or whatever, right? And at the same point of time, in the speaker end also, the same crystal is placed. When this electrical signal, it strikes this crystal placed in the speaker, it creates the same physical movement again, that is, the sound is recreated. So this is one very popular example which, with the help of which you can understand that the piezoelectric effect is actually reversible in nature. Okay, so this is one of the very popular phenomena that is used in biomedical instrumentation. Then we have thermoelectric effect. So that is basically heat giving rise to electrical energy. right? So when two dissimilar metals such as iron and copper, they are joined at both the ends to form a closed circuit, and one of the junctions it is at a higher temperature than the other, a current is set up. The EMF driving this current is known as thermoelectric EMF, and the phenomena is called thermoelectric effect. So basically, whenever you have two dissimilar metals, they are joined at the two junctions you can see in the figure, and one junction is at a higher temperature with reference to the other. There is an EMF developed in this closed loop. There is a current that starts flowing, and anywhere within this closed loop, if you tap and put a voltmeter, like you can see in the figure, you can observe certain voltage being produced. That voltage is actually proportional to the temperature difference between the two junctions. Okay, so the temperature difference can actually be measured with the help of this device in terms of voltage, right? So a voltage can be observed at any point of the interruption in the loop, which is proportional to the difference in temperature between the two junctions. And the polarity of this voltage actually depends upon which junction is higher. And the device which we form in such a way, this is called a thermocouple. Since thermocouple, it measures the temperature difference rather than absolute temperature. So it is very important that one of the junctions is supposed to be kept on a known reference temperature, which is usually 0 degrees or 32 degrees Fahrenheit, 0 degrees Celsius, which is freezing point. So if you keep one junction on the freezing point and the other gets heated up, the voltage that you produce, that you measure, is actually proportional to the difference between these two junctions. So if one is at 0, it is very easy to find out the absolute temperature of the other junction, right? And this phenomena actually is termed as Seebeck effect and Peltier effect. So the use of thermoelectric effect to convert thermal energy to electrical energy is Seebeck effect, and the reverse is also possible. That is, if you apply current, the heat can be produced. So when the flow of current can cause one junction to heat and the other to cool, that is called a Peltier effect. Okay. And the fourth one, most important one, is photoelectric effect. Now, photo means light, right? So over here, we are converting from light energy to electrical energy. So the photoelectric effect is the emission of electrons when the electromagnetic radiation like light hits the material, right? The electrons, they are emitted in this manner and they are called photoelectrons. You can understand when the operated at a small load resistance, the current delivered is proportional to the intensity of light. You can very easily understand in this picture, when the light beam, it strikes the surface of the photosensitive device, the energy from the photons is transferred to the electrons of that particular device, or that particular surface. The electrons actually get excited, they are released from the bonds, and when the electrons are released, a flow of current starts, right? So the energy from the photons or the light particles is actually transferred to the electrons of that particular photosensitive device. The electrons, they break open from their bonds and they become freely moving ions and they start a flow of current. So this particular type of phenomena is called photoelectric effect, and this is also very commonly used, in biomedical applications. So active transducers can actually be based on any of these four principles, that is magnetic effect, magnetic induction effect, piezoelectric effect, thermoelectric effect, or photoelectric effect.